Welcome to our 2020 Basic Online SKYWARN Spotter Training. A little bit about the National Weather Service before we begin training. If you're not familiar with the National Weather Service, we are a federal agency. We sit under the National Oceanic and Atmospheric Administration, NOAA, if you ever heard the acronym of NOAA. And NOAA sits under the Department of Commerce. So that's our line to the federal government. Our mission at the National Weather Service is the protection of life and property. It is a community effort, however. It's not just us. We rely heavily on our emergency management partners, the media especially, to help get our warnings out, county, city, and federal agencies, first responders, amateur radio, and then you, our SKYWARN spotters. Every year, this time of the year, during the late winter and early spring, all around the country, we train volunteers on how to safely observe severe storms and report severe weather back to the National Weather Service. So who is the National Weather Service? Who are we? I'm coming to you from the Austin, San Antonio Forecast Office. We have 122 forecast offices throughout the United States. Our 33 counties we cover here in South Central Texas range from the Austin, San Antonio area along the I-35 corridor up into the Hill Country, and then out west to the Rio Grande, out near Del Rio and Eagle Pass, and then to the east of I-35 all the way out to Lee, Fayette, and Lavaca counties, about halfway to Houston. From this office, we are actually physically located in New Braunfels, Texas. That's where our radar site is, between the two cities of Austin and San Antonio. From our office, we issue forecasts. We issue public forecasts, 7-day forecasts. We issue fire weather forecasts, aviation forecasts. We do decision support, so when there's large events going on or hazardous events going on, we work heavily with our emergency management community in giving them tailored forecasts. We also do local research here and outreach like we're doing right now. And then we are the sole provider of official watches and warnings for South Central Texas. So severe thunderstorm watches, tornado watches, severe thunderstorm watches and warnings, flash flood watches and warnings, winter storm watches and warnings, hurricane warnings, all come from the National Weather Service. So why SKYWARN? Why do we rely on volunteers to help us with our mission of protecting life and property? Well, we have lots of sophisticated equipment at the National Weather Service. We have Doppler radars that have been upgraded that can see a lot of what is going on inside of a thunderstorm. But there are limitations to our Doppler radar. The Doppler radar can't tell us exactly what is going on at ground level. It can show us what's going on several hundred feet to several thousand feet above the surface, but not actually what's going on at the ground level. So we rely on our spotters that are trained to safely observe severe weather and report back to the National Weather Service. They are our nation's kind of first line of defense for severe weather, our eyes in the field. And you will help give communities downstream time to prepare for severe weather. So again, you are going to be trained to identify severe storms safely and report information back to the National Weather Service. Now this presentation is going to be kind of split into two halves. The first half is going to be some definitions, so we're all talking the same language here, and some climatology of severe weather, especially as it relates to South Central Texas. And then the second half is geared towards how storms form, how they become severe, what to look for, and what to report back to the National Weather Service. I should kind of pause here and mention that if any of you are outside of our county warning area that I just showed you, that's fine. This information, especially the second half of this presentation, is applicable to anywhere in the country as far as how to observe severe storms and report back to the National Weather Service. But the first half of it, the climatology portion, is kind of geared towards South Central Texas. So let's first start with some terminology in the National Weather Service and in the weather community. If you've ever been to our webpage, weather.gov, or you've been to maybe the Weather Channel's webpage or your local TV station's webpage, you may see a national map of all the current watches and warnings and advisories, the weather advisories and watches and warnings throughout the United States. And it can get confusing. The terms can get confusing. There could be, on any given day, a lot of active weather going on across the United States. So we're going to break down what these different terms mean. Let's first start with weather advisories. These are issued for weather events that aren't a threat to life and property, not an imminent threat to life and property. They're issued for more of the nuisance type hazards. So things like a dense fog advisory isn't necessarily a direct threat to your life and property, but it's a nuisance. It's going to cause you to slow down on the roadways. You're going to have to leave extra distance between you and the other vehicles around you, and extra time to reach your destination. A wind advisory are issued for those sub-severe winds, the winds maybe 30 to 50 miles an hour that may blow loose objects around, but they're not going to be a direct threat to life and property. Flood advisories and winter weather advisories get a little tricky in this area of south central Texas because flood advisories are issued for those nuisance-type flooding events where there could be some ponding of waters on roadways and maybe a couple low water crossings flooded here and there. But we can quickly, in this area of south central Texas, go from nuisance-type flooding to very high-impact flooding. And so you will often see us kind of skip over the flood advisory terms and go right to flash flood warnings. Same thing with winter weather advisories. It does not take a lot of winter weather precip in this area of south central Texas to start causing a lot of impacts. And you know that if you're in the Austin or San Antonio area. So winter weather advisories are more for those kind of light dustings of snow. The main roadways are kind of fine, light icing events mainly on maybe a couple elevated bridges here and there, but the main roads are fine. And then, we can quickly transition into all of a sudden all the roadways are becoming hazardous and slippery. And so that's when we go with winter storm warnings. Now, weather watches are issued in advance of those hazards, those weather hazards that may become a threat to life and property. So things like tornadoes and severe thunderstorms with large hail and damaging winds, flash floods, hurricanes, winter storms. Watches are issued. Those are all threats to life and property. Watches are issued when conditions are going to be favorable for those weather hazards that are a threat to life and property to form. Doesn't necessarily mean that the weather hazard is occurring or imminent, just that all the conditions are coming together that day for either severe storms or flooding or a winter storm or even a hurricane. So these are going to be issued for large geographical areas. So you can see here on the left, here's an example of a tornado watch. The conditions were favorable that day for tornadoes in portions of central and west central Texas. On the right, you'll see a flash flood watch. The flash flood watch there for the hill country in south central Texas and north Texas. Conditions were favorable that day for flash flooding. I should kind of point out here that flash flood watches are issued by your local forecast offices, those 122 offices I showed you in that opening slide. Tornado watches and severe thunderstorm watches are actually issued by the Storm Prediction Center out of Norman, Oklahoma, and hurricane watches are issued by the National Hurricane Center out of Miami, Florida. Now, weather warnings are issued for those weather hazards that are very imminent or occurring. They're going to be a threat to life and property. So instead of the conditions are favorable that day, now they're actually occurring or very imminent. They're about to occur. So things like a tornado warning, either a tornado is on the ground, has been spotted by one of our spotters, or we're seeing things on radar that leads us to believe a tornado is very imminent. Things like a severe thunderstorm warning, we're seeing an indication aloft in a storm of a very large hail that's about to come down. We're seeing very strong winds that are about to collapse down out of the storm. That would be a severe thunderstorm warning. Flash flood warnings, we're now starting to see many low water crossings flooding, or we're starting to see high rainfall rates that could lead to flash flooding. So with weather watches on the previous slide, those are the days where you're just going to want to watch the weather, pay extra attention to the weather that day, have a way to receive our warnings. And then when we actually issue a warning, that's the time to seek shelter and be safe. And there's a fourth term in the National Weather Service that we rarely use, and that is a weather emergency. And we issue these for flash flood events and tornado events that will or are expected to be that will result in a catastrophic loss of life or cause catastrophic damage. So think of a very large, violent tornado moving through a metropolitan area. We are fortunate in this area of South Central Texas that we've never had to issue a tornado emergency. We have in other areas of the country as you get further north into North Texas and the Dallas-Fort Worth area, up into Oklahoma and in the Moore and Norman, Oklahoma regions. They've issued tornado emergencies before. Now, we have issued flash flood emergencies in this region of Texas, and if you're from this area, you know the high-impact flash floods we can get. Think of the floods that we had back in 2015 during the Memorial Day weekend, the big floods that we had that weekend, the big river flood that we had down the Blanco River that resulted in the catastrophic destruction and loss of life to the town of Wimberley. Those are the type of events that we save our flash flood emergencies for. So we've defined advisories, watches, and warnings. Now let's actually define what we issue. What criteria do we use to issue severe thunderstorm warnings or tornado warnings? And let's start first with tornadoes, the obvious one. And we define a tornado as a violently rotating column of air that's connected from the cloud base all the way down to the ground. It has to be connected to the ground. We issue tornado warnings for those. Now, later in the presentation, I'll tell you the difference between a tornado and a funnel cloud. There is a difference between the two. Severe thunderstorm warnings we issue for large hail events, and that's when we're expecting hail 1 inch in diameter or greater. That's the size of a quarter or greater, and or damaging wind. Now, what I mean by damaging wind? What's the difference between a tornado and damaging wind? So it doesn't take a tornado with air going up into a storm to produce wind damage. And in fact, most of the wind damage that comes from severe thunderstorms actually occurs with winds that collapse down out of a storm. And we call that oftentimes straight line winds. Sometimes you'll hear the term microburst used. And the threshold that we use to warn for the winds that are collapsing down out of a storm is 58 miles per hour or greater. Now, one thing you won't see on the slide is lightning. We do not issue severe thunderstorm warnings for lightning, even frequent lightning, cloud-to-ground lightning strikes, or continuous cloud-to-ground lightning strikes. We don't issue severe thunderstorm warnings for that. Why not? By definition, every thunderstorm has lightning in it. If we were to issue warnings on every single thunderstorm that occurs in this country, people will quickly tune our warnings out. Now, lightning is definitely a threat to life and property, and we want you to seek shelter during lightning, but it's just one of those things that we don't issue warnings for so that we don't oversaturate people with warnings and get people to tune us out. Some other terms to kind of go over here. A few days out ahead of a severe weather event, our Storm Prediction Center out of Norman, Oklahoma, will start outlooking different regions of the country where that severe weather is going to happen. So they're looking long-term, out through 7 days, on where severe weather may occur, where all the ingredients are going to come into play. And they have a scale that they use. If you've ever been to our webpage, if you've ever followed us on social media, your local TV meteorologist will often use this scale too. And it's called our convective outlooks. And they range from just general thunderstorms that won't become severe, all the way from a marginal risk of severe storms to a high risk of severe storms. Marginal risks are those days where we're expecting isolated type severe thunderstorms, limited in duration, limited in coverage and intensity. As you go up in the scale, you'll see that the intensity, the duration, and the coverage of these events increases. Typically in South Central Texas, most of our severe weather events fall in the marginal to enhanced range on the convective outlooks. Every couple of years, we do get a moderate risk here this far south. It's very rare that we actually get a high-risk day this far south into South Central Texas. And in fact, the last time we did was back in 2007. Now, further north, up in latitude, as you get up into North Texas and especially up into the plains, Oklahoma, Kansas, Arkansas, Missouri, that region, they'll have several days of moderate each year. and maybe 1 or 2 high-risk days in a given year. We always recommend people have multiple ways to receive our warnings, not just one way. We often get asked, one of the number one questions we get asked is, do you have a weather app? Does the National Weather Service have an app? And the short answer to that is no, but I'll give you some more information later on our mobile web page. But there are a number of weather apps that are free out there that you can download that will push our warnings from the National Weather Service to you. So I encourage you to look for those apps. Weather radio is another way to receive warnings. If you're not familiar with NOAA weather radio, think of it like a smoke detector for weather. It will alert you at all hours on when a warning has been issued for the county that you live in. Television's another way. Commercial radio is another way. Social media is on here, but there's a question mark next to it. And the reason there's a question mark next to it is you have to be following us, first of all, to get warnings, at least on the Twitter platform. We do push our warnings out on Twitter for all 33 counties that we cover. On Facebook, we don't, though, because Facebook has some issues with algorithms that it uses on how many people we can reach. And also, as you've probably noticed, if you do have a Facebook account, you'll see old information days later showing up. It's the first time you've seen it, and it's old information. So we don't want our warnings kind of floating out there in Facebook land days after they've expired. Wireless emergency alerts are another important way that you can receive tornado warnings and flash flood warnings from the National Weather Service. Currently, we do not push severe thunderstorm warnings out to the wireless emergency alert system, but we do with the tornado warnings and the flash flood warnings. If you're not familiar with wireless emergency alerts, the way it works is our warning forecaster at the National Weather Service will look for those areas where severe weather is imminent or we have confirmation on the ground of severe weather. They will draw a box that looks kind of like a polygon of where the severe weather is and where it's going to go over the next hour. We issue the warning. It gets pushed through the wireless emergency alert system all the way to the cell phone companies. The cell phone companies know where their transmitter towers are in relation to those boxes that we've drawn, and it can trigger the towers in and near those boxes to send those warnings to your phone. And the good thing about this is you can be anywhere in the country and you don't have to worry about following a certain National Weather Service office on Twitter or downloading a certain weather app for that area or bringing your weather radio with you. As long as you have your wireless emergency alert activated on your smartphone, enabled on your smartphone, you can receive tornado warnings and flash flood warnings anywhere in the United States. So let's talk about thunderstorm hazards across South Central Texas and the climatology across not only South Central Texas but the U.S. Now let's start with lightning first. Lightning, as I mentioned, we do not warn on because by definition every thunderstorm has lightning in it, but it is dangerous and deadly. You can see from these two pictures here the dangers, what we call bolts out of the blue. You can see in both these pictures the lightning bolts that have traveled out away from where it's actually raining. We have seen cases of lightning striking up to 10 miles away from where it's actually raining. On average, we see about 20 deaths every year in the United States from cloud-to-ground lightning, but hundreds more are injured every year from lightning. The general rule, safety rule that we like to give people is if you are close enough to hear thunder, even a distant rumble of thunder, that's your time to get indoors. As far as lightning fatalities, and by month, this graph here shows you when lightning fatalities most often occur in the United States. This is for the whole United States. And it's typically during our warm season, peaking in June, July, and August. For Texas, the state of Texas, June is actually our deadliest month, with 7 deaths from lightning dating back to 2006. As far as what people were doing when they were struck and killed by lightning, it's usually some leisure type of activity. It's not they're at work or they're doing some daily routine activity like shopping or something. It's usually they're out camping or playing a sport or fishing, some leisure type activity. Now, where do we want you to go when there's a lot of lightning? Trees are not safe places to be under during lightning. We don't want to seek shelter underneath trees or those pop-up canopies or gazebos. Those are not safe places to be in lightning. Here's an example, a time-lapse from a lightning strike last year at the 2009 FedEx Cup that injured 6 people. So we don't ever want to seek shelter under a tree or a tent or a gazebo. We want to get indoors into a safe building. As a last resort, if you're not near a building or your house, you can use your vehicle, get inside your vehicle, to offer protection from lightning. Now, high winds is a different thing. We'll talk about that later. But as a last resort to be safe from lightning, inside your vehicle should be a safe place to be. Now, let's talk about flash flooding. It is our #1 storm-related killer here in South Central Texas. By far, it kills more people than lightning, than tornadoes, than hail, than heat, than cold. Why is that? There are several ingredients that come into play on why we see flash flooding here in South Central Texas and why we see fatalities from flash flooding. One of the important ingredients is our proximity to the Gulf of Mexico, that moisture source and that fuel for the thunderstorms, how close we are to the Gulf of Mexico, especially in the spring and summer months, and even into the fall, where we're tapping into that deep moisture. Oftentimes in the fall, we can actually even tap into Pacific energy that's coming off hurricanes out of the Pacific that can help enhance rainfall over South Central Texas. The second ingredient that kind of comes into play is the topography and the makeup of the soil around this region of South Central Texas. So as you get along the I-35 corridor, and then especially up into the hill country, the soil depth is very shallow, only a couple inches deep before you hit bedrock. So there's not a lot of soil to soak up the heavy rainfall that we can get. And then the topography, the hills, leads to very quick runoff of that heavy rainfall down into our creeks and streams and eventually our low water crossings. And then the third reason is the population boom that's taken place between Austin and San Antonio and points northward up into the hill country. We're putting more and more people into an area that's already prone to flash flooding. This map here covers our 33 counties in South Central Texas from 1996 to last year, 2019. And shaded here, and the numbers in those counties represent the flash flood fatalities over the last 24 years. 156 deaths from flash flooding, and you can see it lines perfectly up with the I-35 corridor and hill country, where those ingredients come into play that I mentioned on the last slide. Now, those 156 deaths from flash flooding over the last 24 years represent almost half of the state total for Texas. So almost half of all the flash flood fatalities occur here in South Central Texas, in the state of Texas. If you're from the Austin metro area or the San Antonio metro area, I want to pause here and give you two good tools here to maintain good situational awareness from flash flooding. The website there on the left, atxfloods.com, and the website on the right, bearflood.org, are two great resources to go to. On both of these websites, you will see a map with dots on it. Those dots represent all the low water crossings in those regions, and they are color-coded, either green, where they're not flooding at all, or red, where there's flash flooding occurring and are closed. And what's great about this is you can actually subscribe to certain low water crossings that you may often drive through in a particular day. So you can get alerts on when low water crossings are flooded and closed. For the bearflood.org page, right now it just covers Bear County. For the atxfloods.com page, it covers Travis County with the city of Austin, and then the surrounding counties, Williamson, Hayes, Burnett, Bastrop counties. So all the counties kind of surrounding the Austin metro area. We want people to remember the 6-12-24 rule as it relates to flooding. As little as 6 inches of fast-moving water can knock over and carry an adult away. As little as a foot of water, 12 inches of water, of fast-moving water, can start to float most smaller vehicles and carry them away. And as little as 18 to 24 inches of fast-moving water can carry away most large SUVs, vans, and trucks. We don't want you to get this false sense of security that just because you drive a big pickup truck here in Texas or an SUV that you're safe from flash flooding and your big vehicle can make it through a low water crossing. And there's a science behind that. As little as 1 foot of water can displace 1,500 pounds. 2 feet of water, 3,000 pounds. 3 feet of water, 4,500 pounds. And that doesn't even account for horizontal forces that can be put on your vehicle from moving water. This is just standing water. So you start to get in the 2 to 3 foot range of water that's moving, and you can quickly see how even big vehicles like trucks and SUVs can be floated and carried downstream in these low water crossings. Let's talk about hail. Now, fortunately, we don't see a lot of fatalities from hail. It's been a few years since we have, but we do see people injured from hail every year. The biggest threat from hail obviously comes to property, especially vehicles and the roofs on your homes. And it can cause some serious injuries, as I mentioned. We're going to talk later in the presentation about supercells, a type of severe storm. Supercells are often associated with the large hail, the very giant hail. Think like the baseball-size hail, the softball and grapefruit-size hail often comes from these supercells. This supercell here, this 6-inch diameter hailstone there that you see on the right, occurred 2 years ago. It's the largest hail ever recorded here in south central Texas by a supercell that moved through the Smithville region. Now, when reporting hail back to us, we always want you to use a reference. So when it's safe to do so, we don't want you to go out in the middle of a storm, but when it's safe to go out after a storm, collect the hailstones, kind of average them out, to measure them with a ruler or a tape measure, get the average size, and then get the max size, the biggest size that you see, and report kind of the average size that you see on the ground and the biggest hailstone that you found. If you want to send a picture back to us, try to use a reference object in the picture with the hailstones. So that picture there on the left is a bad example because I can't really tell how big that is. Is that small pea-sized hail, or is that quarters that we're looking at, or even a golf ball-sized hail that we're looking at? The other images there are perfect examples. So 2 of them there have rulers. One of them has a bunch of coins referencing the hailstones, and even one of them has an apple referencing, giving us a good reference of how big those hailstorms are. Later in the presentation, I'll give you a way to get pictures back to us. Now, I mentioned it before, that it doesn't take a tornado with wind going up into a storm to produce wind damage in a severe thunderstorm. In fact, most of the wind damage from severe storms can come from winds collapsing down out of a storm. We call those straight line winds, and we also use the term microbursts. And it begins with very cold, dense air that's up in the storm, rain-cooled air that's very cold and dense. And because it's dense and heavier than the air surrounding it, it accelerates very quickly down to the ground. In that initial stage, it hits the ground in what we call the impact stage, and that's the time that it's of greatest danger to people below, to structures below, even to the aviation community in that impact stage. If you were to look at this picture, the static picture here, and I were not to have told you that this was a microburst, you may think that that must be a tornado you're looking at. But as a spotter, just watch this over time, and if you see the things falling out of the cloud, or the rain falling out of the cloud, that's the downdraft, what we call the downdraft of a storm. That's the rain-cooled air accelerating down out of the storm. So that's typically going to be where the microburst is. And then eventually things kind of spread out after it hits the ground. The rain-cooled air starts to spread out. It kind of looks like a foot. If you watch it over time, it starts to spread out away from where it hit. Along the leading edge of where it's spreading out, the air can get kind of turbulent and can continue to cause damage. We call that boundary there where the rain-cooled air is kind of spreading out. The microburst is spreading out away from the storm, the leading edge of the gust front, or the outflow boundary of the storm. So oftentimes you'll hear meteorologists talking about outflow boundaries or gust fronts. That's that leading edge of the rain foot. Sometimes these microbursts can be pretty big, several miles wide. Here's a good example of one over a city. So here's pictures of wind damage, and again, if I weren't to have told you that this was straight line wind damage, you must you might have thought that a tornado must have produced this damage. Some of the straight line wind damage that's collapsing down out of a storm can initially, to just the general public, look like tornadic damage. Large trees that are uprooted, even planes that are flipped over, and power lines that are snapped, and roofs that are taken off buildings and homes. We've seen cases of these straight line winds in excess of 100 miles an hour. So we're talking F1, even F2 type damage on the Fujita scale that I'll talk about here later. These microbursts, these straight line wind events can produce some pretty significant damage. Even the sub-severe microbursts, think of like the 40 or 50 mile an hour winds, not greater than 58, but the 40 to 50 mile an hour winds can pick up loose objects like trampolines that can pose obviously a threat to you. So even around the sub-severe storms, you're just going to have to pay attention to those winds that are spreading out away from it. So I mentioned earlier, there's a difference between a funnel cloud and a tornado. The tornado, again, is a violently rotating column of air that's connected from the cloud base all the way to the ground. There has to be a connection to the ground for it to be called a tornado. A funnel cloud is a rotating column of air that's connected to the cloud base, but there is no contact with the ground yet. So the image there on the left and the picture there on the right, you see two examples of a funnel cloud. It's connected to the cloud base, but if you look closely, there's no connection all the way down to the ground. You don't see debris being kicked up on the ground. Now the picture there in the middle is a little bit more difficult. So the picture on the left and the right, you would report back to us as a funnel cloud. The picture in the middle, you might report that back to the National Weather Service as a funnel cloud, but be sure that you let us know that there is obstructions obscuring your view of the ground level. So in this case, in the middle picture, there is a large tree that's obscuring your view of the ground level. So you can't be quite sure if that's all the way down to the ground or not. Where is Tornado Alley? This map here represents all the tornadoes that we've documented since 1950, about when we began to keep accurate records of tornadoes in the United States. You can clearly see the Tornado Alley that we're so used to hearing about from North Texas and the Panhandle of Texas northward up to the Great Plains. If you look closely, you also see a concentration of tornadoes down in the Deep South. We call that Dixie Alley. And we've seen some very violent and long track tornadoes through that portion of the United States. As you go further south and west of those two regions, and you start to get down towards south central Texas, you do start to see a lower frequency of tornadoes, but we do get them down here. So let's talk about the climatology of tornadoes here in south central Texas, the 33 counties that we cover here in south central Texas. Before I do that, let's just briefly talk about the Fujita scale. The Fujita scale, the enhanced Fujita scale, is a scale from 0 to 5 that ranks the damage produced by wind from a tornado, with 0 being the weakest and 5 being the most violent type of tornado. In south central Texas, 81% of all of our tornadoes are weak tornadoes, EF0s and EF1s. Those have wind speeds up to 110 miles per hour. Those are pretty strong winds. That's going to cause damage, but typically those are survivable type winds if you're within a well-built structure. So you're in a well-built home or a well-built business away from outer walls and windows. So as you can see here, these type of tornadoes only account for 7% of all the fatalities from tornadoes in south central Texas, even though they account for the majority of tornadoes, 81% of all the tornadoes. The difficulty about these type of tornadoes is they're very difficult to see on radar, especially the weak EF0s. They won't often extend as high up into the atmosphere as the stronger type tornadoes, and they're not on the ground as long. Typically only a few minutes, and sometimes, depending on how our radar is sampling the atmosphere, they may go missed. So don't be surprised if many of these actually go unwarned. Here's some typical type damage from a weak EF0. You can see some roofing material peeled off that home, and some roofing material actually removed from this business there on the right. This was an EF0. So survivable type winds as long as you're in the safe portion of these structures. Strong tornadoes, EF2s, EF3s, these have wind speeds of 111 to 165 miles per hour. These account for 18% of all of our South Central Texas tornadoes, so a lot less compared to the weak tornadoes. But they account for 42% of all the fatalities here from tornadoes in South Central Texas. So now those type of wind speeds are going to start to cause some considerable type damage to even the well-built structures. Now, if there is a good thing about these, it is that they are usually pretty identifiable by Doppler radar. The circulations within them are pretty strong, pretty wide, and extend pretty high up into the atmosphere. So usually we see these, and most of these have warnings on them. So we usually give communities downstream good time to prepare from these type of tornadoes. Here's some damage from an EF2 tornado, and now you can start to compare what I showed you from the EF0 a couple slides ago to the damage here in a stronger type tornado. And this occurred in the Alamo Heights Ridgeview area on the north side of San Antonio back in February of 2017. And you can see whole roofs removed off of structures and outer walls collapsed in on garages and trees twisted there and power lines snapped. So a lot more type of damage from these tornadoes. And then our most violent tornadoes, the EF4s and the EF5. These have wind speeds over 165 miles per hour. In the cases of EF5, sometimes over 200 miles per hour. We're very fortunate that these account for less than 1% of all of our South Central tornadoes. But when they have happened, they have accounted for just over half of all the fatalities. So now we're talking about serious winds here that can cause catastrophic destruction to even well-built homes. Again, these are very identifiable on Doppler radar. We usually get good reports, obviously, from our spotter, but there's usually no missing these on radar. And here's some damage of what an EF5 looks like. This is from the town of Gerald, Texas. And by the way, the last EF5 tornado that we've experienced in the whole state of Texas occurred in the town of Gerald, Texas, just north of Austin, between Austin and Waco, in 1997. So we've gone a long time since we've actually seen an EF5 in Texas. And you can see here the damage, whole homes wiped off their foundation, and trees debarked, and then asphalt taken off roads. These two maps here are from last year, 2019. The map there on the left with all the red dots are all the tornadoes that occurred in the United States last year, roughly about 1,700 tornadoes, slightly above average year. The map on the right are all the severe storms that produced the straight line winds, the winds that collapsed down out of a storm, over 18,000 of those. And that's typical in a given year. This was not an unusual year last year. And in a given year, we normally see 10 times as many storms that produce severe straight line winds versus tornadoes. Okay, so that's kind of the first half of this class, the definitions, the hazards to look out for, the climatology of severe weather. Now let's kind of get into the meat and potatoes here. How storms form, how they become severe, what to look for as a spotter, and most importantly, how to stay safe and report back to the National Weather Service. Let's first talk about ordinary thunderstorms, non-severe thunderstorms. How do they form? What do we look for? We typically need three ingredients for an ordinary thunderstorm to form. We need moisture, and typically, as I mentioned, in the spring and the summer, we have a good amount of moisture in our deep southeasterly flow off the Gulf of Mexico that moves into South Central Texas. We need something called lift, to lift the moisture in the lower and middle portions of the atmosphere vertically upwards to get it rising to form a cloud. Typically things like cold fronts, warm fronts, the dry line in West Central Texas, areas of low pressure, upper level disturbances can all help lift air in the atmosphere. And then we need a term called instability. What is instability? Instability just generally describes once we get things vertically moving up into the atmosphere, how far are they going to go up into the atmosphere, and how fast is the air going to rise up into the atmosphere? The more unstable the air is, the higher and faster it goes up into the atmosphere. The more stable the air is, it tends to act as a lid on the atmosphere and suppress things from air from vertically growing up into the atmosphere. So those three ingredients we look for: moisture, instability, and lift for an ordinary thunderstorm. When we have those three ingredients in place, we start to get a cloud to form, and not just a puffy cumulus cloud that you see on an average spring or summer day, but something that's more towering in nature like you see here in this image. A towering cumulus stage is the first stage of the life cycle of an ordinary thunderstorm. All the motion is upward in this picture that you're looking at. We call the air that's rising up into a cloud and eventually a thunderstorm the updraft of the cloud or the thunderstorm. The updraft is taking the fuel, the moisture, vertically up into the atmosphere. It's cooling, it's condensing and forming cloud drops. The cloud drops quite aren't heavy enough to fall back down as rain yet in the towering cumulus stage. In the mature stage, the raindrops eventually grow and grow and grow bigger in size, and they're eventually heavy enough to fall back down. Sometimes there's small hail in there too in an ordinary thunderstorm. That rain and the rain-cooled air and the small hail that falls back down during the mature stage of the thunderstorm falls down to what we call the downdraft of a thunderstorm. So in this picture here, you see a much different looking cloud. The previous picture was just looks like a small tower. Now the storm is much bigger and more crisp in nature. And so you have an updraft and a downdraft briefly that coexist briefly during the mature stage of the thunderstorm. Eventually that rain-cooled air, as I talked about earlier, when we talked about the microburst, hits the ground and it starts to spread out in all different directions with a gust front or an outflow boundary. And eventually that gust front or outflow boundary chokes off, it cuts off the updraft. It cuts off the fuel source for the thunderstorm. And the whole thunderstorm collapses and dissipates. So now this picture looks a lot different than the previous picture. It's not as crisp. The top portion of the cloud is much more wispy in nature. We often call that the orphaned anvil of the thunderstorm. The top of a thunderstorm is the anvil, and when it starts to look more wispy like that, and it becomes detached from the thunderstorm, the wispy upper part of the thunderstorm becomes detached. We call that an orphaned anvil. That whole life cycle from beginning to end of an ordinary thunderstorm is pretty quick. It might surprise you. It can only be about 30 to 60 minutes to get air rising and forming an updraft, cloud drops becoming heavy enough to fall back down through the downdraft, and eventually the outflow boundary cutting off the updraft and the whole thing dissipating. So it was 30 to 60 minutes. So what do we need to take an ordinary thunderstorm and turn it severe? And there's a fourth ingredient in the atmosphere we look for called wind shear. Wind shear helps those ordinary thunderstorms become severe. What is wind shear in the atmosphere? Wind shear, as you go up into the atmosphere, as you move up, is defined as an increase in wind speed and or a change in the direction of the wind. And why is that so important? I'll show you that here by drawing on here. If you follow the updraft here, it doesn't go straight up when there's wind shear in the atmosphere. It gets tilted downwind. And that's important because as the downdraft forms, it falls out away from the updraft. It doesn't fall right through the updraft or near the updraft. It falls downwind of it. And because of that, the updraft, which is the fuel source for the thunderstorm, and the downdraft is bringing all the bad weather back down, can coexist for a lot longer period of time, allowing the storm to grow stronger and more strong and eventually severe. And then wind shear also in the lower levels of the atmosphere can play a role in tornadogenesis. So on those days where we have the three ingredients in place, the moisture supply, a lifting mechanism, and kind of low to moderate amounts of instability, are days where we see ordinary thunderstorms, single-cell thunderstorms. Sometimes they'll form into clusters called multi-cell thunderstorms. On days where we increase both the instability in the atmosphere and we add wind shear into the atmosphere, are days where we get organized severe weather, usually in the form of squall lines or supercells. And we're going to talk about those here shortly. Some things to look for as a spotter when you cross from just an ordinary thunderstorm into a more severe type thunderstorm. The first is just generally a camera factor, as I like to call it. You're out away from the thunderstorm many miles away, and you're looking at it, and it's much more bigger in appearance, and as you're watching it over time, the updraft is starting to billow out a lot faster. You ever watched a severe storm form and kind of watched the updraft grow up into the atmosphere? Sometimes it can look very explosive in nature, indicating very strong to severe updrafts. Crisp edges and cauliflower-looking appearances to the updraft are all visual clues to start to look for. I mentioned the top of a thunderstorm is called the anvil. Oftentimes, if you're out many miles away from a thunderstorm, you'll see a distinct cut-off of the storm and a flat top to it. That's basically a point in the atmosphere where the updraft reaches a stable layer and it can't go anymore, so it spreads out beneath the stable layer. And it looks flat, and we call that the anvil of a thunderstorm. As a spotter, if you watch that anvil and you start to see a new top developing on top of it, we call that an overshooting top. What's that indicating? Essentially, just kind of boiling it down, it is indicating that the updraft strength, the velocity of the updraft, has strengthened so much that it can punch through that stable layer and can keep going above the stable layer. So anytime you start to see these overshooting tops on top of the anvil, it's an indication of a very strong, usually tilted type updraft in a thunderstorm, a clue that you could start to see a severe storm to form. You can see these overshooting tops many miles away. This picture here, the main picture here in the middle, is of a severe thunderstorm that produced baseball-sized hail near Giddings, Texas. Now, this picture was actually taken near Canyon Lake, 85 miles away. This is of a supercell, a classic-looking supercell. The flat top that you see there, the anvil of the storm, on top of that you have an overshooting top. Now, as you're closer in towards a severe storm, the first two things I like to tell spotters to look for are, number one, where do you see it raining, things falling out of the cloud? Here in this picture, it's on the right. This is where the rain is, and if we were to see any type of microburst, it would be off on the right side of this picture. Hail would be falling on this side of the picture. That's the downdraft of the storm. The next thing to look for is, where do you see a rain-free base, a dark rain-free base? And that's in the middle and left portion of this picture. That's the markation of air rising up into a storm, the updraft of the storm. So things falling out of it is the downdraft again, and the rain-free base next to the downdraft is the updraft of the storm. As that updraft grows higher and higher into the atmosphere, that rain-free base becomes darker and darker and darker. Sometimes it might look pitch black outside, an indication of very tall updrafts that have grown so high up in the atmosphere that sunlight can't penetrate back down to the ground. So find those two things here. Again, on this picture here, the downdraft is on the right. The heavier objects, the larger hail, usually fall out first, and the smaller hail gets deposited further downwind, and the rain further downwind. Also, again, the downdraft portion where you would see the gusty winds, possibly severe straight-line winds, would be off in that region. And then in the middle portion of this picture, and on the right, is the rain-free base, marking the updraft of the thunderstorm. And why is the rain-free base so important to watch? Over time, what you want to watch in these rain-free bases is a lowering of them. Sometimes the rain-free base will start to gradually lower and broadly start to rotate. Don't think of something violently rotating like a tornado yet. But this broad, slow rotation and lowering of the rain-free base beneath the updraft is what we call a wall cloud. Wall clouds are important because tornadoes can form beneath wall clouds. Tornadoes form in the updraft portion of the thunderstorm, the air rising up into a storm. Wall clouds descend out of that rain-free base and start to broadly rotate, and then some other things happen in the atmosphere that we get to in our advanced SKYWARN class, where we can take those wall clouds and get tornadoes to form. Now, not all wall clouds will actually produce tornadoes, so don't think that just because you see a wall cloud that you're going to get a tornado. In fact, many of them won't. But this is something to report back to the National Weather Service because it can give us lead time on tornadoes. Here's several great pictures here of wall clouds. The one there on the right, a classic one. This was taken down in Victoria, Texas. And you can see the rain-free base kind of in the background of the picture here. I'll kind of mark it here on the left. Kind of goes back behind the wall cloud and then off to the right. And then you see the wall cloud, the lowering of the rain-free base that's come out. And over time, that spotter observed this wall cloud broadly rotating. This wall cloud actually, believe it or not, did not produce a tornado. And in the pictures here on the left, on the top left and bottom left, you can see the rain-free base in both of them, and this lowering of the rain-free base that's occurred, and this broad rotation was observed by the spotters in these two pictures. Again, wall clouds, and something to report back to the National Weather Service if you ever observe a wall cloud. This cloud is called a shelf cloud. Unlike the wall cloud that is associated with the updraft of the storm, the shelf cloud is associated with the downdraft of the storm, the rain-cooled air that's spreading out. Remember the gust front and the outflow boundary that we talked about earlier. The leading edges of that rain-cooled air is where the gust front, or sometimes we call it the outflow boundary, is located. Along that gust front or outflow boundary, you can get a cloud that forms. That rain-cooled air lifts warm, moist air back over it, and a cloud forms, and it looks like a long shelf, an indication of the markation of where the stronger straight-line winds would be within a storm. One distinguishing difference between the two, the wall cloud and the shelf cloud, is shelf clouds are usually a lot longer. They can go many miles in length. Wall clouds are much smaller, sometimes only a few hundred yards wide, sometimes a mile wide. The shelf clouds also point away from the direction it's raining. So in this picture here on the right, you see the rain kind of off in the lower portion of the right image behind those wind turbines, and the shelf cloud's actually pointing away from the direction it's raining. Sometimes on a wall cloud, the wall cloud can take on this appearance that it might be pointing back towards the rain, the opposite direction as the shelf cloud. Again, shelf clouds are associated with the downdraft, so think straight line winds. Wall clouds associated with the updraft of the storm, and it can be a region where tornadoes can form. Okay, we talked about just a minute ago squall lines and supercells. Those days where we get all four ingredients, moderate amounts of wind shear and instability in the atmosphere can lead to squall lines forming. On radar, bottom right there, is what squall lines look like. They're going to look very different from the picture I'm going to show you here in a minute of supercells. Squall lines can go many hundreds of miles in length. They're initially very linear in appearance on radar. They look like a straight line on radar initially. Over time, though, if you look at that lower left illustration there, sometimes they can take on the shape over time of a bow. Think of a bow and arrow. And it's at the points of these bows where the strongest winds are, sometimes severe winds, straight line winds are. Squall lines often can become severe at that point, where you start to see these, what we call bow echoes on radar. Squall lines are most often associated with widespread straight line wind damage. They can produce hail. It's usually not going to be the very big giant hail. It's mainly going to be the straight line wind threat out of squall lines. They can produce isolated tornado spin-ups along the leading edges of them that are very short-lived and can be come with not a lot of lead time. It's just difficult to get lead time on these type of tornadoes. Those pictures there that I showed you earlier in the presentation of the EF2 damage in San Antonio in the Alamo Heights region back in February occurred in a squall line. Squall lines are dangerous and difficult for spotters. We're not teaching you in this class how to go out and chase storms. That takes many, many years of experience to do safely. We're teaching you to safely observe severe storms and report back to the National Weather Service. And one of the reasons we're not teaching you how to go chasing is because squall lines are very difficult to get out of the way of. They're just many, many miles to hundreds of miles in length. And these bow echoes can show up at a moment's notice and catch spotters and chasers off guard. And these tornado spin-ups that occur along the leading edges can often spin up very quickly and can pose a risk to spotters and chasers, and oftentimes people can have a difficult time getting out away from these severe storms. Here's an example from last severe weather season, April 2019, out near the Rio Grande, of a squall line that was coming out of Mexico across the Rio Grande into Maverick County near Eagle Pass. So it's moving kind of left to right. On the picture on the left, we call reflectivity. Where is it raining? The picture on the left. That line of storms was moving out of Mexico into Eagle Pass. And you can see the bow-shaped appearance to it, just off to the west of Eagle Pass. The picture on the right is what we call the velocity mode of the Doppler radar. So it is looking how fast are objects up in the sky, raindrops or hail or even debris, moving towards or away from the radar. The radar can estimate wind speeds aloft, above the ground. Again, the limiting factor of the radar is we can't see what's going on the ground, but we can see a few hundred to a few thousand feet off the ground, depending on how far we are away from the radar. So that picture there on the right is the velocity, how fast things are moving towards or away from the radar. You can see just to the west of Eagle Pass as this bow echo was approaching. Up above the surface, we were estimating winds of over 60 knots, 60 to 80 mile an hour winds, just a few hundred to a few thousand feet off the surface in this bow echo. Now, supercells are very different in appearance on radar and then structurally as you look at them visually as a spotter. All the clues that I talked about earlier, the visual clues, you can often see in a supercell. That camera factor, as I mentioned, the billowing nature and explosive nature of the updraft. So let's first find the first two things I told you to look for. Where's it raining? And you can see kind of off to the middle right portion of this picture, the rain. That's the downdraft coming out of the storm. Where's the rain-free base? Off to the left of that. And if you follow the rain-free base up into the cloud, up to the overshooting top that I mentioned earlier, you can see the rain-free base is tilted. So the updraft is tilted with height. What does that indicate? I mentioned that earlier. That indicates wind shear in the atmosphere. And wind shear is that fourth ingredient that we need for severe storms. Beneath the rain-free base, you can see the wall cloud. If you were to watch that over time, it would slowly descend out of the rain-free base and broadly start to rotate. And then every once in a while, you can get tornadoes that form beneath the rain-free base, beneath the wall cloud. Now, supercells are most often associated for the larger type hail events, the golf ball size hail, the baseball, softball, grapefruit size hail. They're often associated with tornadoes too, especially our stronger tornadoes and our more violent tornadoes. And they're longer lived. They're usually discrete, isolated individual storms that can last sometimes many hours. And so they can pose a significant threat to life and property. From a radar perspective, when you look top down on a supercell, this is what they look like on a radar. That top left picture there is a classic looking supercell on radar. It has this hook-shaped appearance to it, or this comma-shaped appearance to it. Basically what you're looking at top down on radar is the points of these hooks, and I'll circle that here in yellow, is the updraft. That's the updraft of the storm, air rising up into the storm. That's where a wall cloud might be, like you see here. That's where a potential tornado might be. As you get out away from the hook and you get back towards these purple pixels back in there, these dark reds and rusty-looking colors back in there, those are the big raindrops and the hail that might be within a supercell. So that's going to be your downdraft off to the north, off to the north of that hook. So that's where the downdraft is. That's where you might see the large hail, the very heavy rainfall. And then out along the leading edges of the storm is where you might see the shelf cloud. Again, an indication of the gust front or the outflow boundary. Not all supercells produce tornadoes. In fact, most actually don't. Here's a classic supercell that went over our radar site out near Del Rio back in 2001. The radar site there, the picture of the radar on the right, is not how it's supposed to look. It's supposed to be a perfect sphere. Winds collapse that inward. This supercell produced severe straight line winds that collapsed down out of the storm. It produced a microburst right over the radar site that collapsed the protective layer of the radar inward. And we estimate a wind speed of over 100 miles per hour with this supercell. So again, these supercells not all produce tornadoes. In fact, most actually don't. But when they do, oftentimes the stronger tornadoes, the more violent tornadoes come from supercells. Here's a supercell a little bit closer in towards the I-35 corridor from last year, April 6, 2019, just off to the east of San Marcos, between Lockhart and San Marcos. Classic looking supercell, but you see the hook-shaped appearance, the comma-shaped appearance to it. This one did not produce a tornado. It did produce large hail, though, up to golf ball-sized hail. The pictures there on the right were from spotters, trained spotters. Now, what's good about these pictures? I told you that earlier. There's a reference object with those pictures. The top picture there shows a coin with it. The bottom picture there, a tortilla chip actually, is used as a reference. A little climatology about tornadoes here in south central Texas. This is for our 33 counties. We talked about the intensity of tornadoes in climatology earlier, so now let's just talk about all tornadoes that form. Only 10% of them have occurred with supercells in this region of Texas. Only 10% of them. 90% of them have come from those squall lines that we talk about, clusters of ordinary storms, or even in outer rain bands of hurricanes and tropical storms. So the majority of our tornadoes are the more difficult type of tornadoes to warn on that come from tropical rain bands or squall lines that are quickly spinning up. Let's talk about some safety information and then how to report back to the National Weather Service and some spotting techniques. These pictures here of tornadoes, we know that there's tornadoes here because there's a connection down to the ground. We can see the debris being picked up off the ground and being lofted upwards. Sometimes, especially in the initial stages of a tornado that has just formed, you won't visibly see a connection between the funnel hanging out of the rain-free base, what we call the condensation funnel, and the debris being kicked up on the ground. It looks initially kind of invisible between the two. This can be dangerous or difficult as a spotter because if you do have large trees in your way or buildings in your way, it can obscure debris that's occurring. So just keep that in mind if you're spotting near a region that has a lot of trees or buildings. Maybe keep an extra distance between you and that storm just in case it is on the ground. Sometimes tornadoes can get obscured by rain, and there's a tornado in that picture, a large wedge-shaped tornado. Oftentimes in supercells that have a lot of rainfall in them, we call them high precipitation supercells, and that are strongly rotating. The rain can actually get wrapped all the way around the updraft and where the tornado is, and it can obscure what the tornado is. That's a dangerous thing to be around if you're a spotter or a chaser. Same things with a squall line. There's a lot of rain in the squall line. The tornadoes can quickly get wrapped up in rain within a squall line. These pictures here, we often get calls from the general public mistaking these as tornadoes. These are what we call scud clouds. These are non-rotating clouds. The difference between these and tornadoes is they aren't rotating if you watch them. And they're usually detached in the rain-cooled air. So if you watch them over time, there's not going to be a connection to cloud base, and they're not rotating. We do not need to know about these. These are usually harmless type clouds called scud clouds. Some things to kind of look out for if you're down along the coast. This is very common if you're down along the mid or upper Texas coast where there's lots of refineries that are producing smoke or steam. Those can rise into cloud bases and give the illusion of tornadoes. But even here closer to home, this picture was taken on the east side of Austin near the toll road. There's a power plant on Walter Long Lake, and that day the steam coming off the power generation from that plant happened to be rising into a cloud base that wasn't even precipitating yet and gave the illusion of a tornado. This picture here was taken from the San Antonio area down on the southeast side from 8 miles away from Calaveras Lake where there is a power plant. and you can see the smoke rising off the smokestack there into the cloud base of an ordinary shower. It wasn't even producing lightning yet, and the illusion that it gave you of a tornado. So just be aware of your surroundings if you're near a power plant or in an industrial type of area, and there's low cloud bases that day that steam or smoke could be rising into them and giving you the illusion of a tornado. We want to do this safely as a spotter. Again, we're not teaching you how to chase. We want you to stay a safe distance away from these storms. We want you to wait until they pass to go out and measure the rain or the hailstones. No report is worth risking your safety or your life. That's very important. As far as how close to get, to view some of these lower level clues like the wall cloud, you'll need to be in slightly closer, 1 to 4 miles away. Is a pretty safe distance to view these type of low-level features. If you want to look at the upper-level features like the tilted updraft, that camera factor to the storm, the overshooting top, you're going to need to be out many, many, many miles away from the storm. You can't be right underneath it. So always be aware of where you are in relation to these storms, how they're moving, what direction they're moving. Realize sometimes that, especially with supercells, they can change direction quickly. So they might be moving off to the northeast, and all of a sudden they turn eastward or even southeastward. Always have a safe shelter to get to, a close, safe shelter to get to. And again, always have a way to receive our warnings. I'm going to mention this again because we talked about it earlier, and I'm going to mention it because it is our #1 storm-related killer here in South Central Texas by far, flash flooding. Again, the whole report is worth risking your life and safety, so never, ever drive through low water crossings that are flooded. And these two pictures here of the same low water crossing are a perfect illustration of that. The picture there on the left is a picture of an average normal day where it's not flooded. The picture there on the right is when it's flooded. If you're not familiar with this low water crossing, you would have no idea how deep that road went down into that creek riverbed there, and you would have no idea that there's many feet of water over that road. As far as places to be in high wind and tornadoes, we talked about cars earlier. We're going to talk about that here in a minute as far as how it relates to high winds. The safest place we want you to be is inside a well-built home or business. Interior rooms and lower floors of those homes or businesses are the safest places to be. So think of like an interior closet or an interior bathroom. Basically, you want to put as many walls between you and that tornado or that high wind. Be aware of flying debris out there. Flying debris can hurt and kill you. Here's some debris that was picked up in tornadoes on the left and right there in San Antonio. 4x4s easily punched through walls. The picture there in the middle is actually a surfboard, believe it or not, that was punched through the side of a house. The worst places to be. By safe homes, well-built homes, I am not talking about mobile homes. Those typically do not fare well in severe type winds. So we want you to be in a safe building, safe home or business. Now, vehicles. We talked about vehicles as far as lightning goes. As a last resort, that's a safe place to be, inside your vehicle from lightning. As far as high wind, this is where the research gets a little tricky. There's been some research out there lately that has shown that in weaker type tornadoes, the EF0s, that it could be, as a last resort, a safe place to be inside your vehicle. That does not hold up for the stronger type tornadoes, though, the EF2s and 3s and 4s and 5s. Now, the difficulty is that if there's a tornado coming at you, you have really no idea of how strong the winds are within that tornado. So at this time, we do not recommend vehicles a safe place to be in high winds. Highway overpasses. We've put this one in our slide deck here over the last few years because we've seen cases of people stopping underneath highway overpasses to ride out severe storms. Maybe you don't want to get your vehicle damaged by large hail. Two things going on that's dangerous in these pictures, in this highway overpass picture. First one being you have vehicles that have stopped in the main lanes here, And when you start to get into the heavier precipitation that's resulting in lower visibility, and you're coming up on this highway overpass, you won't have a lot of lead time to know that there's vehicles stopped there. So you can create an instance where you can start seeing vehicles collide. The second reason is wind speeds can actually be higher underneath the overpass than they are, say, a few hundred yards out away from it. The winds can actually accelerate through and beneath those overpasses and result in higher wind speeds than would be the case just a few hundred yards out away. How to report severe weather back to the National Weather Service. This 800 number that's on the screen, I will also have on the very last slide. So if you don't have a chance to write it down right this moment, I'll have it on the very last slide. This is our number for the National Weather Service office in the Austin, San Antonio area. This will get you to our forecasters here in our 33 counties. If you're outside of our county warning area, say you're up in the Dallas area or Houston area or maybe down in Corpus Christi or maybe in a totally different state, you can still report severe weather back to your local National Weather Service office. I will give you my contact information at the end, my email address, and if you want me to find your severe weather reporting line for your local forecast office, I can do that for you. What to report back to the National Weather Service? Tornadoes, obviously. We talked about wall clouds earlier, the descending of the lowering of the rain-free base where it starts to broadly rotate. Funnel clouds we need to know about. Hail of any size, so not just the 1-inch diameter hail or greater, the quarter-sized hail or greater, but even the penny-sized hail, the nickel-sized hail, the pea-sized hail can help us calibrate what we are seeing on radar. So report hail of any size back to us. After it's safe to do so, after the storm has passed, if you come across any wind damage on your property or out and about, please report that back to the National Weather Service. Any flooding, report back to the National Weather Service. Don't drive through flooded low water crossings, but if you come across any flooded low water crossings, please report those back to us. And extreme rainfall amounts. If you have a rain gauge at your house that's properly sited, away from trees and buildings, report rainfall back to us, especially extreme type rainfalls. And what do I mean by extreme rainfall rates? Typically, especially in the metro areas here in Austin and San Antonio, about 2 inches per hour of rainfall can start to cause some issues in the metro areas. So use that as a rough guideline. Social media. We talked about that earlier. Twitter, we send out our warnings on Twitter, not on Facebook. But you can use social media to get reports back to us. If you're on Twitter and want to get a report quickly back to us, use the hashtag EWXSpotter. We monitor that feed, EWXSpotter. So you have a picture. The quickest and easiest way to get a picture back to us is to tweet the picture with the hashtag EWXSpotter, and we will immediately see it. Even if you don't have a picture, but you just want to get a report back to us, use hashtag EWXSpotter. You can also submit pictures to us on Facebook. I'll be honest, we're not as actively monitoring, as quickly monitoring Facebook as we are Twitter during a severe weather event, so Twitter's the best way to get reports back to us. Or you can call that 800 number that I gave you. If you want to get a picture back to us and maybe you don't do social media, call the 800 number. You will speak to a forecaster. It rings right into our operations and tell them that you would like to get us a picture, and they will give you an email address of who's on duty, and you can email the picture to us. I mentioned earlier we don't have an app on the Weather Service, but we do have a mobile web page that essentially serves as an app. Mobile.weather.gov is a great thing to bookmark to your home screen there. You can get radar information, satellite information on there, forecasts on there, and a technical forecast discussion that our forecasters put out that kind of gets down into the weeds of things of what we're expecting the next 7 days. Real briefly, as we kind of wrap up here, I want to point out a website called CoCoRahs, CoCoRahs.org. If you do have a rain gauge on your property, again, that's properly sited, away from trees, away from the eaves of your house, and you want to report daily rainfall back to the National Weather Service, not just right after a storm, but daily rainfall, that can be useful to us because it can help Give us conditions on how our radars might be biased, how much rain actually fell, how the soil moisture is kind of doing, how much rain is kind of going off into our river systems that can help us with our river flood warnings. There's a program run out of Colorado State University called CocoRAS.org. It's free to sign up for an account. You can report your daily rainfall back to them through their website, or there's a free app you can download, and they share that data with the National Weather Service. And so you go daily to this form. Here's the form if you were to use the web-based version on a PC. Report your daily rainfall in the morning, which you observed, any snowfall if it's in the wintertime. Now, I should point out, too, because you don't have to check it every day. Let's say you go on vacation for 5 days, you come back, and it's rained several days while you're gone. You can report a multi-day total back to the National Weather Service. Here's what it looks like. Here's an example from one of our flooding events back in 2015. You see all the network of CocoRAS volunteer observers across the United States and the cluster of them that we have here in South Central Texas. You can actually zoom down into a street level view on this and start to actually compare rainfall observations with your neighbors. So it's a pretty neat website and a great way to report rainfall back to the National Weather Service. And again, that's CocoRAS.org. So that wraps up our spotter training. We appreciate you coming out and wanting to be a part of our volunteers that are trained every year to report National Weather Service severe weather. We want you to do it safely. And here's our contact information. I promised that. It was all going to be summarized on one slide. There's our 800 number. Again, that goes to just our office here in South Central Texas. There's our websites, weather.gov/Austin, weather.gov/San Antonio. They both go to the same exact web page. Our mobile web page, and our social media information. And again, hashtag EWXSpotter if you want to tweet a report or picture back to us. And then our contact information at the very bottom. My email address is jason.runyon. My colleague is nick.hampshire that helps also do these SKYWARNs. If you want to email me with any questions that you may have, maybe it's not even related to severe storms, any type of weather questions, feel free to email me at any time, jason.runyon@noaa.gov. Again, if you're outside of our county warning area, a different region of Texas or the country, and you maybe want the spotter contact information for your local forecast office, go ahead and email me at jason.runyon@noaa.gov, and I'll track down that information for you.